Hello students, in this module we will discuss the resistance of a system of resistors. What will be the effective resistance when we connect the resistors in series and resistors in parallel. Next we are going to discuss resistance of a system of resistors. There are two methods of joining the resistors together. One is we can connect all the resistors in series, and other one is we can connect all the resistors in parallel. We will see in detail what is the effective resistance when we connect all the resistors in series and what is the effective resistance when we connect all the resistors in parallel. See here this circuit diagram. Three resistors are here. The resistance of each resistor. Resistance of first resistor is R1, second is R2 and third is R3. All the three are connected in series. Then the voltage across all these three together, it is V, and I is the current flowing through these all resistors. This is the circuit diagram. Now we connected a voltmeter across each resistor separately. Then according to Ohm's law, you can see what is the voltage across each resistor. So you know that I into R1, that will be the voltage across this resistor, and here I into R2 here, and here I into R3. That means voltage across each resistor is different. It depends upon the resistance of the resistor. The voltage across the first resistor V1 is equal to IR1, V2 IR2 and V3 IR3. But the current I is same through all these resistors. All these resistors, the same current is flowing. So the net voltage, net potential difference across all these resistors together, that is V is equal to V1 plus V2 plus V3. From the previous activity, we have seen that V is equal to V1 plus V2 plus V3. We measured the potential difference across all the resistance together, and V1 we measured the potential difference across each resistor individually. Then we have seen that V is equal to V1 plus V2 plus V3. Let I be the current through the circuit. The current through each resistor is I. So we can say that V is equal to IR, and together we write V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. So V is equal to V1 plus V2 plus V3, that is IR is equal to IR1 plus IR2 plus IR3. We can conclude that RS, that is all the resistors connected in series, is equal to R1 plus R2 plus R3. When we connect so many resistors in series, the effective resistance is the sum of the individual resistance. If we connect n identical resistors in series and each resistor having a resistance R, then the effective resistance Rs is equal to N into R. Now we will see what happens when we connect three resistors in parallel. See here, 3 resistors in parallel. Here, 2 circuit diagrams I am showing. Here, we are measuring the voltage across this resistor individually and the current through this resistor also individually. And here, the voltage across all the 3 resistors same, because we connected this voltmeter parallel to these all resistors, and the ammeter is also measuring the main current through this all 3 resistors. We will see what will be the change in the voltmeter reading and ammeter reading in these 2 cases. Here we can see that the voltage across each resistor is same. This reading and this reading same only. But the ammeter reading, it is different. The current through this resistor and current through the whole, it is not the same. So when we connect 3 resistors in parallel, the current through each resistor is different, but the voltage across each resistor is same. So we can say that the main current I through this circuit is equal to the current through the individual resistors I1, I2, I3. That is, I is equal to I1 plus I2 plus I3. That is, V by Rp is equal to V by R1 plus V by R2 plus V by R3. Here Rp is the effective resistance when we connect these all resistors in parallel. R1 is the resistance of the first resistor, R2 is the resistance of the second resistor, R3 is the resistance of the third resistor. So we can conclude that 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the effective resistance, we can say that the reciprocal of the equivalent resistance of a group of resistance joined in parallel is equal to the sum of the reciprocal of the individual resistance. So if you connect n identical resistance in parallel, then the effective resistance Rp is equal to R by N. So what is the conclusion here? When you connect the resistors in series, the effective resistance is more than the individual resistance, and when you connect in parallel, the effective resistance is less than the individual resistance. We have already discussed about series and parallel connection of resistance. Now, this is a simple household circuit. See here, this table lamp, this toaster and this TV all are connected parallel. That means you can independently control each device. Any of this device become damaged, it will not affect the working of other devices. This is the advantage of parallel connection over series connection. If you connect an electric bulb and electric heater in series, they need current in widely different values to operate properly. So according to the requirement, the different device will take a different current. So both will not work properly. Another major disadvantage of series circuit is that one component fails, the circuit is broken and none of the components works. If you have used fairy lights to decorate buildings on festivals, on marriage celebrations, etc., you might have seen that the electrician spending a lot of time in trouble locating and replacing the dead bulb. Each has to be tested to find which has fused or gone. On the other hand, a parallel circuit divides the current through the electrical gadget's resistance in parallel circuit is decreased as per equation 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3.